questions of this chapter. Okay, and the important part of this chapter we're going to discuss this one today. Okay, so what we're going to study that today we're going to study the sign conventions. Okay, and what are the major problem that a student is going to have when they were having a numerical problems regarding to this one. So what are the those problems that uh, person or student is going to have in this one? So we're going to focus this one today. Okay, so first of all, we're going to discuss the image formations that is taken by, and the student should need to note that while solving the problem, so what he need to do is, what he need to keep in mind is the proper sign convention. Okay, proper proper sign convention should be there. Use of proper sign. Okay, proper sign conventions. Okay, proper sign conventions should be there. So if I'm talking about this one, that a student must have or must keep in mind that first of all, when he or she is solving the problem, what he need to keep in mind is that she must use the proper sign conventions of U, V, F, whatever it is given to you. So that proper sign convention should be given. Second is that prediction of approximate value, approximate value, value of the answer. Third is orally or without solving. I'm just talking about that without solving, predicting the approximate answer of that question that is being given to you. Okay, means we should predict that what is the approximate answer of this question. For example, some questions, some values are given to you, so it must be predicted that this approximate answer you are going to get it. Okay, and when and how you are able to predict that one, that value or the oral, by just keeping up, means by just revising that where the object is kept here in the, and where the image is going to form. Okay, this type of means orally making an image of the object and its image formation, and its image formation and its image formation. Got it? Got it? So these are the things that a student should keep in mind that while solving the numerical problem related to lights. So for example, if I'm having this concave lens, okay, sorry, concave mirror, not a lens. And if I'm having this concave mirror, so this is the focal length, this is the radius of curvature. Right? If I complete this circle as a whole, so there will be always some center or some point where we're going to have, or we'll put this value. Okay, when we complete the circle, we're going to have its center, and this is called center of curvature, half of the radius. We can say that if I'm having a circle, if I'm just completing a circle here like this way, okay, and this is a sphere like this, and if I'm having this center, so this will be considered as center of this one, and half of this will be considered as focal length. So now, similarly, if I'm having this concave mirror, and if I'm just having this value, and if I'm just putting this one like this way on a proper as x and y axis. So this is positive x-axis, this is negative x-axis, this is positive y-axis, this is negative y-axis. Okay, so may I know that if you are measuring the height of an object, if you are just measuring the height of an object, do you think that will you keep it uh okay, do you think that will you keep it positive value or the negative value? Height of the object. Tell me. Height of the object. Will you consider it as positive or negative?
Positive.
It would be positive. Height of object will be considered as always positive. Why? Because it is always measured in positive y-axis, and positive means we are just, it is arbitrary chosen that we will always keep the object upside. Okay, like this way. Okay, and whatever the and always the object should be placed on the left hand side of the uh, we can say that Cartesian planes, okay, or we can say it on the negative x-axis. So if I consider this distance from this one, is it a positive value? Will you measure this object distance when positive or negative? Object distance. So we will say that height of the object will be considered as always positive. Object distance will be considered as negative always. Okay, object distance will be considered as negative. Got it? Now, moving further, if we are having, like suppose, if I'm having image formed by mirrors, okay, let's have the focal length. Let's consider the focal length. Now, the focal length of this concave mirror, if you are just considering, if you convert this one as a whole cycle, whole one, so you will always find this center here, means on the negative x-axis. If it is a negative x-axis, so this focal length will be also considered as negative. Why? Because if you are having center here, the focus will also be there, na? Focus will also be there. So we will say that for a concave mirror, for concave mirror, okay, focal length is considered to be as negative. Got it? For concave mirror, whether it is concave mirror, concave lens, both has the negative focal length. Got it? Now, if I consider this one, that image formed by the mirror, concave mirror is both real as well as virtual image. When it is forming a virtual image, then object should be placed between pole and focus. Are you getting my point?
Yes, sir.
That when we are having this object, let's suppose if I'm just placing this one object between pole and focus, then an enlarged image will be formed here. So this distance is in the positive x-axis, so this will be considered as positive. And here this object distance will be considered as negative. Object distance will be always considered negative. So here the image distance for mirrors is considered to be as positive if virtual and negative if real. If real image is formed, then it will be going to form here. It will it will be formed here, it will be formed here, anywhere, but it will be in front of the mirror. It will be measured, image distance will be measured on the negative x-axis, so it will be considered as negative values. This distance is in the negative x-axis, so this will be going to have negative values. Okay, so we'll say that if the image is real, then we will have the value as negative. Got it? V as negative. Image distance means V will be considered as negative. Okay, got it?
Yes, sir.
Yes, you everybody got it?
Yes.
Jobita, Jaslin, Shoaib, understood?
Yeah.
Okay. So let's move further. Moving further, if we have the next one is, let's suppose I'm just making here some cases for you. Let if I'm having, you just remind me and you need to help me, okay? This is focus, this is radius of curvature. If I put the object beyond R, where the image is going to form? Where
Between
the
R and F,
will it be enlarge or diminish?
it will be diminished.
It will be diminish. Okay. If I'm just having, if I'm just putting the object exactly at R, exactly at R, what will be the image formed by this one?
Same size.
It will be of same size as the object. Okay, this will be at R. It will be of same size. Okay, if I'm having, let's suppose if I'm putting the object here between R and F, then where the image is going to form?
Beyond R,
So it will be going to form beyond R. Will it be enlarged or diminish?
enlarged.
It will be enlarged. So you notice here that if the object is beyond R, the image is diminished. It will be same size when it is exactly at R, and when it comes closer to the mirror, then its size will keep on increasing. Okay. Now, if the object is placed at exactly at focus, then where the image is going to form?
It's infinity.
Infinity.
Highly enlarged.
Highly enlarged. So we'll consider this one as highly enlarged image. Okay. So you know that as we are just moving or we are just coming closer to the focus, are you noticing this one? As you are coming closer to the focus, your image is also going back or away from the mirror. You see that here it is between pole and focus. As you are moving exactly R, it will be exactly R. If your object is coming between R and F, then the image is shifting beyond R. As you move further, then it will be moving towards, tell me, it will be moving towards focus. Sorry, if you are having exactly at focus, then it will be moving beyond R. So as you keep on moving up to focus, the image will be formed or moving backward. Okay, got it? And vice versa is also true. Vice versa is also true. If you keep the object at focus, then it will be at infinity. If you move the object beyond between here at this position, then the image will shift here, will come closer to the mirror. As you move the object away from the mirror, the image will come closer to the focus. And if you put the object at infinity, then the image will be at focus. Image will be at focus. So what I'm just having here, just I want to know, or just I want to concentrate you that if the object is coming closer to the focus, then the image will go away from the focus, or it will keep going away from the focus. It will be going away from the mirror. Okay, and if you exactly keep it at focus, then it will be at infinity. Image will be formed at infinity. Similarly, if the object is placed at infinity, then its image will be formed at focus. And here is a specialized case that when the object is placed between R and F, sorry, between pole and focus, then this is a specialized case, then concave mirror is going to form say a virtual image behind the mirror, and that would be enlarged. Okay, understood? That will be enlarged image is going to form there. Enlarged image is going to form there. So if we go through a question that we are just going to have in our examinations, and the type of question that is being asked, okay, similar for the lenses also. Concave lens and convex lens have the same property. Let me explain you the concave lens also, because they both have, sorry, convex lens also. This is the convex lens. Okay, this is the convex lens. Why it is convex lens? Why it is convex? Because as you see, convex mirror is like this. Convex mirror is like this. And if you see the object we are just putting here, we are just having a face, oval shape face, not the curved face. Here we have this type of face. So this same for the lens also. Here we have. So in front of the object, this face is visible to this one. So we will consider it as a convex mirror. Sorry, convex lens. Got it? Understood? Okay. Understood this
Yes,
one?
sir.
Tell me fast. So this is the way that why they both are going to have the same name, this convex and this one, because the facing towards the lens is same. Okay, towards the object is same for both the cases. Now let's move. Now we are just having this one. This is the focus. This is the radius of curvature first, R1, and this is another focus, and this is radius of curvature, R2, F1, sorry, F2 and R2. Now, simple. If the object is placed beyond R, then the image will be formed between R and F. If it is bigger in size, because it is object is away, so it will be image will be diminished. Got it? Got it? Now, if it is exactly at R, if we are having exactly at R, object exactly at R, then the image would be formed exactly at R. As we come closer to this one, so closer to this one between R and F, so the image will go away. I have told you that if the object is coming closer to this one, it will keep going, the object will keep going, or image will keep going away, and it will become enlarged. If you put the object at exactly at focus, then the image will be formed very large, and it will be at infinity. And the same cases for this one and for this one is that when the object is placed in case of concave mirror, if the object is placed between pole and focus, here the virtual image is formed behind the mirror. In mirrors, virtual image is formed behind the mirror. But in lenses, the virtual, or sorry, real image is formed away from this one. It is not formed on the same side. It is formed away. So if I'm talking this one, that if we have an object which is placed here, okay, which is placed here between here. So its image, where its image is going to form? Will it form here? Tell me.
Same side as object.
Yes. In this case, here we will going to form the same size as the object. Same side, not size. Okay. And here it is not of a specific means it is not a specific value is not given that it will be formed beyond R, between R. No, it will be same side. It can form here. It can form here. It can form here, depending on the object where it is placed. If it is more closer to the lens, then it will be away from this one. If it is uh means if it is nearer to the focus, then it will be closer. So this is the same thing. Okay, so here the virtual image is formed. This is the virtual image, and this is object. This is object, and this is its virtual image. Virtual image. So virtual image in the lens is formed at the same side. Okay. Now, can you tell me that the V here in this case, V in this case of lens, V in case of lens, will it be positive or negative? Object distance, sorry, image distance, will it be positive or negative? If the virtual image, in case of virtual image, V will be positive in case of lens or negative?
Negative.
It would be negative. Why? Because here the object distance is considered to be in negative x-axis. So it will be negative. V should be negative. And here the V for the real image will be positive. V will be V, or yeah, we can say that image distance will be positive. Got it? Image distance will be positive. Okay. So what you learn here is that you have to take the sign. Okay. Proper sign convention you have to take, positive, negative, and you have to solve it accordingly. One more thing you have to note it down, that whether it is concave lens or concave mirror, they both have positive focal length. Positive focal length. You need to keep in mind. Okay. You need to keep in mind that whether it is a concave lens or concave mirror, both are going to have if it is concave, then both are going to have positive. Okay. Got it? Sorry,
Yes, sir.
concave, we have, for concave mirror, we have negative focal length. We have negative focal length. Okay. Whether it is concave mirror or concave lens, both have negative focal length. And whether it is convex X, you can say that X, if you tilt it like this way, you will get positive value. So if we have convex lens or convex mirror, they both have positive focal length. Okay. So this is valid for both, whether it is mirror or lens. We are just going to have both of them. We are just going to have same sign, whether it is concave or mirror or convex. Sorry, concave mirror or lens. Okay. Got it? Got it?
Yes,
Tell me
sir.
fast. Okay. Now, one more thing that we're just talking about the magnification. Magnification sign is important. Magnification sign is important. If I'm talking about the magnification, then the magnification for real image is always taken as negative, and magnification for virtual image is always taken as negative. Virtual image is always taken as positive. Got it? Understood? For concave mirror or concave lens, negative focal length, common for both. For convex lens or convex mirror, focal length will be positive. Magnification, whether it is a lens or a mirror, I'm just talking for both. Okay. Whether it is a lens or a mirror, we are just going to have, if it is a real image, we will take the magnification as negative. If we have virtual image, then we are going to have the positive. One more thing you need to understand here. One more thing, that if the magnification is exactly equal to 1, then it means same size image. same size image as object is, if the magnification is greater than 1, means if it is greater, for example, magnification is height of image upon height of object. How it can be 1? When we have this value more and this value less, this will be greater than 1. So it means image is more, so height of the image is more and the height of the object is less. Means it is magnified image. Okay, magnified image is this one. This is magnified image. And if the magnification is less than 1, it means it is diminished image. Diminished image. Diminished image. Okay. So we shall be discussing this one. I'm just writing here some values of magnification with proper sign. I'm just indicating this one again, that if it is positive sign, it is indicating a virtual image. If magnification is, if I'm talking positive, then it will be virtual image. And if it is negative, then it will be indicating real image. Real image. Okay. Now I'm just writing here 0.5 with positive sign. Okay. Then we have plus 1.25, sorry, negative 1.25, then plus 1.2, and then minus 1, and then plus 1. Okay. Tell me which type of image it is and where the object is placed and which type of lens it can be or mirror can be. Tell me. If it is positive 0.5, what does it mean? What information you are getting with this one? And where
It is
the
a
image is
vir-
being?
it is a
Visual.
virtual diminished image formed by a convex mirror.
Convex mirror. No, not convex mirror. Yeah, convex mirror, na? Okay, convex mirror, yes. And convex mirror or lens can be concave.
Concave, yeah.
Okay, so you have to look at this, that this is a positive. Positive means virtual. Less than 1 means diminished. Okay. And virtual diminished image is only formed by this type of mirror. This is convex mirror. Convex mirror. And if it is convex mirror, then you need to keep in mind, whatever a convex mirror is going to form, the same thing is formed by concave mirror. Concave lens, sorry. Concave lens. Okay. So this is concave lens. The same thing is formed by concave lens. Okay. Now tell me this one. Because virtual image is formed by plane mirror also. Virtual image is formed by, okay, first come to this point here. I'm just going to ask you one thing. Can you tell me that what is the difference between the virtual image of plane mirror, concave mirror, or convex lens, or convex lens, and third one is convex mirror or concave lens. What is the difference between these three? What do you mean by what is the difference between the plane mirror, the image formed by plane mirror, virtual image formed by plane mirror, concave mirror, and convex lens? Tell me. Why the other students are not participating? Jobita,
Yes, sir.
why are you not answering? Jaslyn, Shoaib,
The mirror forms visual image.
the plane mirror is going to form virtual image. They all are going to form the virtual image. What is the difference between the virtual image of plane mirror, concave mirror, and convex mirror?
The plane mirror will form virtual image of same size as object.
Yes, it is going to form +1 magnification image. Virtual, indicating virtual, and +1 means exactly of same size. What does this means? Concave mirror.
It will be enlarged.
Yes, whenever it is forming a virtual image, so it will be, its magnification should be greater than 1. Okay, so its magnification should be, we can say that magnification should be greater than 1, with positive sign. Yeah, the positive sign means, positive sign does not means that +1 or -1 which is greater. No, positive sign is indicating real and virtual bus. It does not means less than 1 or greater than 1. Okay, positive. Okay, and next, this one,
Diminished image will be
whenever a
formed by
convex mirror is going to form the image, then it will be always diminish, always enlarge. Okay, always enlarge, and this will be always of same size. Always of same size. Got it? So let's have some numerical problem based on this one. Just a minute. Do question number 35. And first do it by your own means. Tell me that where the object is placed, where it is going to get, what would be the values of each and everything that is given to you. Write their proper values with sign. With sign. The image of candle flame formed by a lens which is obtained on a screen placed on the other side of the lens. Okay, if the image is 3 times the size of the flame. Okay, first of all, it is obtained. The image of a candle flame formed by a lens is obtained on a screen. So if it, what does it means? If it is obtained, information, tell me, what
it is
information
real.
do you get? It is
Real image.
real image. Real image it is. Okay. Now on the screen on the other side of the lens, it is simple. That other side of the lens, the image formed is always real. If the image is 3 times the size of the flame, what does it mean? 3 times of the size of the image. What does it mean?
Magnification is 3.
So you write magnification is +3 or -3.
-3.
It will be -3. Why -3? Because real. Okay. And the distance between the lens and the image. And the distance, this is important. The distance between the lens and the image. What does it mean? The distance between the lens and the image?
Image distance V is
V.
80.
V is 80 centimeter. So can you tell me the sign of this one? V is positive, negative?
Positive.
Positive.
Yes, it will be positive. Why? Because this is a real image is formed, and real image by a lens is formed here. And this is the, if you take it, this is the positive x-axis. Positive x-axis it is. It is the negative x-axis. So since the image is formed is real, and it is a lens formed real image on the positive side of the x-axis. So that's why it will be considered as positive. Don't write the any sign here. If you write it 80, it's okay. Then at what distance should the candle be placed from the lens? Tell me what distance, what is being asked? U
U.
is being asked. You need not to write U with negative sign because it will automatically come with negative sign. The values that are unknown or that are we need to find out in the question, we are not going to write their symbols. They will become automatically with their own symbols. Okay, means you will come with negative sign. It is, what is the nature of the image at a distance of 80 centimeters from the lens? Nature, you need to find out the nature, whether it is enlarged, magnified. So it is already given magnified. It is given real and magnified. But you need to find out the value of this one. Okay, so how will you able to find out this one? What is the value of U? This is very simple. Which formula you are going to use?
Magnification formula.
Yes, M is equals to
V by U.
V by U. For lens we have V by U, and for mirror we have -V by U. Okay, so you have to put it -3 is equals to plus of 80 and then minus of u. Sorry, only u, not minus of u. Okay. Then this u will goes to that side. You will get u is equals to 80 minus 80 by 3 as the answer. Got it? Got it?
Yes, sir.
Now if I ask you to calculate the focal length, please try to calculate the focal length of the lens. Try to calculate the focal length of the lens.
So 1/20.
Okay. Focal length is 1 by 20. So let's check which formula you are using.
1/f equal to 1/v minus 1/.
Okay. Okay, let's check. You can use any formula, whichever you like. But I have a specialized formula. But if you want to have that formula, which you can use any. 1 by f is equals to 1 by v minus 1 by u. Okay. So you need to find out 1 by f. What is the value of 1 by v? It is 1 by 80. Then minus with what's the sign? What is value of u? U was 80 by 3 minus 80 by 3. So value of 1 by u will be 3 by 80 minus 3 by 80. So you will put it and you will get 80 as an LCM. And this minus sign will get plus here. So you'll get 1 plus 3. So you'll get 1 by f is equals to, so you are saying 1, you will get 4 by 20. Here you are just making a mistake, sorry, 4 by 80. 4 by 80. And you told me, Jobita, that the answer is 1 by 20. No? Actually, answer is 20.
20.
You have to reciprocal this one.
Yes.
Next. You can use a direct formula here that we have derived this formula in terms of magnification. F is equals to mu upon, if it is lens, it is formula is 1 minus m. And if it is mirror, we have the formula mu upon m minus 1. This is the formula for, you can find out. You can use in terms of magnification if u is given to you. Okay, so you can use this formula also if you like. And we have the formula, common formula for calculating the focal length. If you know the v, and this formula is f is equals to v upon 1 minus m. And it is common for both, no change. Is it exactly same for both mirror? For both mirror and lens. Mirror and lens. Okay, so you can either calculate by using this formula. F is equals to, what is v? V is 80. Okay, minus 1. Okay, and you have to keep in mind that here the lens is actually convex, so its focal length, you find that it is positive. So here you need to keep in mind that if your sign is not coming properly, it means you have committed some mistake. So here also you have to put minus sign is of the formula, and you have to put the magnification, because it is a real image, you have to put it with proper sign -3. Then you put it like this way, f is equals to 80 upon minus will get plus, you will get 1 minus, you will get plus 3, you will get 80 by 4, you will get 20. So this is the direct formula for calculating this focal length if you have the image distance. Okay.
Yes, sir.
Do anybody want to copy this one?
Yes, sir.
Please copy. Next, if I move further, draw the ray diagram between this and means diagram should be properly learned to you. Okay, if you are not means if you are facing any problem with the diagram, then it's your mistake. Then you have to correct it. Okay. Please try to solve this question number 38. What does this question number 38 is saying? A student focused an image of a candle frame with a wide screen on a convex lens. He noted down the position of the candle of the screen. Please do this one. So how can you tell me what is the value of V, U and F in this question? What is the value of V, U and F in this question? Can you tell me?
Sir, U is plus 12. U is minus 12.
U is minus 12. It means you have not solved this question. So please read this question thoroughly. Read this question again. U is, you are saying U is 12. Actually, U is not 12. U is always calculated from the object, sorry, from the lens. Okay. So I'm going to help you. In this question, what you are going to do. Okay. So here, a student focus an image of a candle flame on a white screen. White screen. So first of all, it is focusing on a white screen. It means it is a real image of a convex lens, and he noted the position of the candle of the screen and the lens under the position. So we have a graph. Sorry, when we do the experiment. So in that experiment table, we have this table. Okay, this is an experiment table. Just look at that. You are looking it above, and this is the table. Means this is the table, and you are just over it. Okay, like we have a book over it. So you are just this is a table, and on this table we are just having this frame, and on this frame we have here 1 2 3 4 5 6 7 8 9 10 minutes up to 100. We have the readings. Okay, so if I'm saying that the candle is placed at a 12 centimeter from here, it means that the from here is 0 and candle is placed 12 centimeter from this one. Here the candle we have placed. We can say here the candle is placed. Okay, we can say here the candle is placed. At this position, we have placed the candle. Okay, at 12 centimeter. And here at 50 centimeter means from here, 50 centimeter, we have placed a convex lens. So we have placed a convex lens here. We have just placed a convex lens here. Okay, and at a distance of 50 centimeter, and the image is formed at a distance of 88 centimeter from this one. Means image is formed at a distance. Here the image is formed of this candle, burning candle. Okay, so here the image of this candle is formed at a distance of 88 centimeter. Now tell me what is F, what is okay, tell me first what is U and what is V in this case. What is F, what is U and what is V?
Sir, U is minus 38.
Yes, U will be considered as minus 38. Okay, okay. Okay, and V will be?
Plus 38.
Yes. Okay. Okay, okay. So you can get plus of 38. So here we have 50. Up to here we have 50. Okay, and here we have until here we have 38. Sorry, 88. So here this will be 38. Okay. So U is 38, V is 38. What does it means? Where the object is
Object is at
placed.
R1 and image is
Yes.
formed at R2.
Yes, we will say that object is, because when we have object distance and image distance same, then it means the object is placed at radius of curvature, because here we will get M is equals to minus V by U. When you put it, sorry, not because it is a length, we will put V by U, not V minus V by U. So this is minus of plus of 38, plus of 38 upon minus of 38. You cut it, you will get minus of 1. Minus indicating real image, 1 indicating same size. And same size image of this concave convex mirror is formed when object is placed at radius of curvature. So it is placed at radius of curvature. Got it? So here we are going to have it is placed at radius of curvature. Okay, got it? So here, if the radius of curvature is at 38, radius of curvature is at 38, then what will be the focal length? Tell me.
19.
It will be 19. Okay. It will be 19 centimeters. Now, what is being asked here? What is the focal length of the convex lens? So we have calculated. Where is the image be formed if we shift the candle towards the lens at a distance of 31 centimeter? So if you are just shifting this at a distance of 31 centimeter, then where the image is going to form if you put the object? Tell me. Okay, the question is, where should we kept, if we are just keeping the candle at a distance of 30 centimeter, then where is the image? Image is going to form. Yes, tell me. Image is going to form. Tell me where the image is going to form. Yes. Yes, you, Jovita. Abir. Another students. Yes, it is correct. Abir, are
Yes,
you
sir.
there?
Yes, sir. 1 minute.
In a simple case, if the object, you are placing the object at 31, then how far it is from the lens? Tell me fast. How far will it will be from the lens? The lens is 50 from this one and 31 you have placed. So you have, the lens will be at 19 centimeter.
Yes, sir. 9. At
And if it is,
focus,
and if the object is placed at focus, where the image is going to form? At, yes,
infinite.
infinity. Image will be found at infinity. Okay. What will be the nature of the image form if we further shift the candle towards the lens? Tell me.
Virtual.
Yes. If we further shift, it means that he is shifting the candle between focus and optical center. Because if we even shift the candle again, virtual, erect, magnified, and same side as the object, same side as the object. Okay, in case of lens, it is same side. And draw the diagrams in case of third. So will you be able to form the diagram?
Yes, sir.
Next. Okay. Do question number. What should be the answer for question number 26? Read the question number 26 and do this. Question number 26. Read this question, please. So what is being given here? Okay. Sudha finds out the sharp image of the window plane on her science laboratory is formed at a distance of 15 centimeter. Means he find that the image. Okay, Sudha find out sharp image. Sharp image means it means where the image is formed, that is considered to be as image distance. Okay. Of a window pane of her science laboratory and is formed at a distance of 15 centimeter from the lens. So here the V is forming at a distance of 15 centimeter from the lens. Now she tries to focus the visible, now she tries to focus the building visible to her outside the window instead of now she is focusing. First of all, this is a window panel or whatever it is, and it is a convex lens. Okay, and she find the image of this window. Okay, here on the here on a screen, somewhere on a screen. Now she is not wanting to focus this one. She want to focus a building which is which is at a distance of means away, which is away or which she is looking from the window. So she wants to focus. So can you tell me, in order to obtain the sharp image, will she bring this closer to this lens or away from the lens?
Closer to the lens.
Yes, she should. Yeah, she will be moving. We know that we are discussing it. I was discussing this one in this case also, that if you bring the object closer to the lens, the image will shift away from the lens. Up to focus, I'm just talking this one. The image will shift away from the lens. And if you bring the object away from the lens, then the image will shift closer to the lens. So when she was targeting the object, this object which is closer, this screen will be away from the lens because the object is closer, then the image will be, sorry, screen will be away or image will form away from the lens. But when she is targeting a distant object, means it is beyond R, then object will be between R and F. Sorry, between pole and focus. Sorry, between R and F, yes. Or we can simply say that if the object is going away, then the screen will come closer to this. Okay, up to focal length or up to focus, the screen will come. Maximum distance of screen can come closer is its focal length. Okay, because it is making a real image. So if you place the object at infinity, then the screen you have to put at focus. So here she tries to focus the building visible to her window instead of window pane without disturbing the lens, without disturbing. So lens is that, so in which direction she move her screen to obtain a sharp image, and what is the approximate focal length of the lens? So what is the approximate focal length? So it will be less than 15 centimeter. Are you getting my point? Are you getting my point?
Yes.
That if the she is focusing her, so we can say that this will be uh, beyond R, okay, or beyond radius of curvature, whatever she is, okay, where she is putting, we don't know, but actually we can consider that if she is putting, and it is saying enlarge image is found or not to me. Enlarge image, is it written enlarge or diminish? Sharp image panel on the laboratory. So we can consider that if it is the enlarged images from, then this window is it between focus and radius of curvature. Okay, radius of curvature and focus. And if it is forming a diminished image, still a diminished image, you know that window is always bigger. So an screen is not of that of window size. So it may be probably the window will be placed here so that the image will be formed between fold and focus. Sorry, between R and F. So it will be approximate focal length will be. So if this is in this case, if we are just placing this one and it is 15 centimeter, so we can say less than 15 centimeter. Got it? Because it is not given anything that it is forming an enlarged image or something. But the final answer for this one is that in which direction she should move the lens. So if the object is going away, then the screen will come closer to the lens. If the object come closer to the lens, then the screen will move away from the lens. It is vice versa. Okay. Will you remember this one, Jobita? Shoaib? And other students? Will you remember this one? Jaslyn? Okay. Now, going to the next part is do this last question 20. Not 20. Do this last question 25. 25.
Yes, it is a correct statement.
Convex lens of focal length 20 centimeter can produce a magnified as well as real image. Is it a correct statement? Yes. If yes, where shall the object be placed in this case of images? Tell me.
For real image, object on 20 or more than 20. For virtual, less than 20, between focus and optic center.
Yeah. For real, it can be at exactly at 20. For real image, is exactly at 20 or more than 20. And for virtual, it should be less than 20 centimeter. Okay. So, is there anything that you are facing any problem regarding to this image formations or the image formed by this one? These images, how the lenses are forming, how the convex lens, concave mirror, another means all the four or five lenses and mirror we have togetherly. So is there anything that is bothering you that you didn't understood that what the concept is behind this one? Is there anything? Tell me. Is there anything that bothers you that you think that this you are not getting something, you are having problem while solving such type of problem, you are not able to understand the question or something else? Tell me fast. Abhi, is there any problem?
No, sir.
You, Jobita?
No, sir.
Jaslyn? Jaslyn?
Okay.
In the next class, what we are just going to discuss here is the refractive index from this portion. Most of the question that is being asked. So refractive index, we need to do that one more time.